Have you ever stopped to think about how the internet could actually run out of anything? It sounds kind of impossible, right? Well, it happened. We literally ran out of the internet's original addresses. And the story of how we got there is this wild mix of absolute genius and some truly epic mistakes. From the very start, this was the magic number, 4.3 billion. Okay, so if you want to get technical, it's 4,294,967,296, but let's just stick with 4.3 billion. It's a number so big that it seemed, absolutely endless. So what is this number? Well, it was the entire original address book for the internet. We call it IPv4. Every single device, from the very first clunky servers to the first computer in someone's home, needed one of these unique numbers just to connect and talk to each other.
And that, of course, brings us to the central mystery. With 4.3 times billion options, that's more than the entire population of the planet back then. How on earth did we manage to burn through all of them? It just doesn't seem possible, does it?
Look, the folks who came up with the internet, they were beyond brilliant, no doubt about it. But they just couldn't have predicted what the internet would become. I mean, they didn't see the explosion of personal computers coming, let alone smartphones, smartwatches, or hey, even smart refrigerators, all needing their own unique address. And that little blind spot, well, it led to some pretty interesting decisions. All right, so clue number one in solving this mystery lies in how they first decided to organize all those billions of addresses. They had this grand plan, this ambitious structure they called the class system. And it turns out it was fatally flawed right from the beginning.
This whole thing was called classful addressing. And on paper, it probably looked great. Let's just force every single IP address into one of 5 neat and tidy little buckets. But that tidiness, that organization, came with 2 absolutely catastrophic side effects that nobody saw coming.
So here's how it worked, and it's pretty simple. The very first number in any IP address automatically decided its class. So if your address started with, say, a 10, bam, you are a Class A, meant for a gigantic organization. If it started with 192, you are a Class C, designed for a small home network. And that decision was baked in from the very beginning. No exceptions.
And this brings us to the first massive flaw in the plan, and the scale of it is just staggering. Because of this super rigid class system, the people in charge of the early internet just started handing out addresses in unbelievably huge chunks.
Now, here's the most crucial detail. If your organization was given a Class A network, you didn't just get a handful of addresses. Nope. By default, the system just handed you a block of more than 16 million unique IPs. The rules only cared about that first number, leaving the other 3 parts of the address totally wide open for you. This chart just shows you how utterly wild that is. I mean, look at that comparison. A single Class A block could support almost 17 million devices. Meanwhile, a typical home network, a Class C, can handle about 254. It was literally like using a firefighter's hose to water a single potted plant. Just incredible overkill. And this quote, it really captures the mindset perfectly. The governing body back then, called IANA, was basically the Santa Claus of IP addresses. They had what they thought was a bottomless bag of gifts, and they were just like, here you go, have 16 million addresses, Merry Christmas.
So who got these giant presents? Well, it was a who's who of big tech at the time. Companies like IBM, HP, AT&T, they were each just handed a block of over 16 million IP addresses. Did they actually need that many? Almost definitely not. But hey, that was the only size the system was offering.
Okay, so that massive waste was problem number 1. But believe it or not, the second problem is maybe even more baffling. It turns out that huge sections of that 4.3 billion address space were just roped off from the start, completely unusable, untouchable. 2 entire classes, D and E, were just taken off the board. Class D was set aside for a special thing called multicast, and Class E was mysteriously locked away for experimental stuff. And just like that, poof, hundreds of millions of addresses were gone before a single person could ever use them. Now, if you were paying really close attention to that chart a minute ago, you might have noticed a weird little gap. Class A ends at 126, but Class B doesn't start until 128. So, what happened to all the addresses that start with 127? That's another 16 million addresses that seemingly just vanished into thin air. The answer has to do with something called a loopback address. It's actually a really simple but important tool. It's basically a way for your computer to send a message to itself just to do a quick systems check and make sure its own networking gear is working right. It's kind of like talking to yourself just to make sure you can still hear.
And here is the absolute punchline. To do this simple self-test, a computer only needs one single address, 127.0.0.1. But for some reason, the Internet's creators decided to reserve the entire 127 block, that's over 16 million addresses, for a job that only needed one. It's just mind-boggling.
So now we can finally see the whole picture. When you combine that unbelievable wastefulness with these huge, untouchable blocks of addresses, you get a perfect storm. The original grand plan was pretty much doomed from the start.
The big takeaway here is that it wasn't just one mistake. It was a whole series of them, and they all grew out of that first decision to create a rigid class system. They gave away way too much, and then they locked away even more. They were just burning through a supply that was supposed to last forever.
So, as the Internet started to explode in popularity, and this address shortage became a real crisis, the engineers realized they had to do something, and fast. The solution wasn't to invent a whole new system from scratch. It was much simpler. They just decided to start breaking the rules of the old one.
This led to a huge shift from what we call classful to classless networking. So instead of being stuck with a 16 million address block, whether you needed it or not, you could now chop that block up into smaller, much more sensible, custom-sized pieces. It was a move from that rigid, wasteful system to one that was flexible and efficient. You could say networking got no class.
But here's the thing to leave you with. Going classless was a brilliant hack, a total game changer that bought us a lot of precious time. It was the first major band-aid on the problem. But we all know how the story ends. We still eventually ran out of those IPv4 addresses. Which leads to the real question, what was the next, even bigger band-aid that keeps our modern internet from falling apart today?